Welcome everyone to more RISC computing here on our All Things Low Level and Linux channel. We are still building our Linux distribution enterprise and business ready, proving that here with the latest and nearly latest but greatest epic thread ripping RISC. Yesterday UltraSpark, today IBM 64-bit Power 8. And yes, that is not nearly the greatest, but we are working on it. So each live stream or each test is a win, right? Also, where are my each day some workspace mapping here. We are already running LS CPU, our precious little Indian Power 8 with IBM Centaurs screaming here already on the balcony. It's so quiet, right? Nearly. It's like windows closed, stuff on the balcony. I hope the neighbors don't call the police on us. Probably fine. So, Power 8. Each live stream a win. I want mostly, of course, testing. More testing. The system is relatively new to us. I only got it this year, 3-4 months ago. Didn't use it the most yet because we have so much to do. So using the stuff we got. And I already found something because as so often boot quirks and stuff, it boots with petite boot like K-boot, like PS3, obviously, right? Of course, new stuff, new also ZAS drive, right? Serial storage and so on. But one thing is, so like each time I waste 30 minutes of remembering how I freaking network booted it with this quirk and that quirk and another quirk, it's like, obviously we can't win business bits like that, right? You want to get into the German government, you better get your IBM shit running. Because nobody ever was fired for choosing T2 Linux. So I wanted to document also the performance, and the one thing I found, so let's rebuild bin utils, obviously. Bin utils. For also we don't. So this is a slightly older. What do we load? We are loading bin utils. Okay. How do we get text files? That's slow. It's a slightly older T2 installation, right? Also watch our precious 80 threads of execution. Beauty. Oops, I pressed something. Do we have NeoFetch? We have NeoFetch. So T2 a little bit older from 2 months ago. Yeah. For us, as fast moving as we are, it's a little bit older from 2 months ago, like or from 1 month ago. Like, okay, now what do we have? Yeah, from 2 months ago. It's a little bit older from 2 months ago. Yeah, 2 months ago is old. So yeah, rolling release, source distribution, it just builds it. So it's guesstimating that at 3 minutes 29 from previous BTOP build. Let's see how it does it. Let's basically see how it compares to our yesterday's Sun server. And yeah, if you're wondering, yes, we're building a data center, in case it wasn't clear. I mean, Exacode is investing. Exacode, previous forward-looking press release. My company planning to invest 20 million in open source Linux and microkernel technologies. We better get our data center infrastructure going. So 5 minutes 33, let's hope the IBM Power doesn't disappoint and builds it faster. Can't see the full terminal. What do you mean you can't see the full terminal? You can't see the full terminal? So, oh, you mean okay, probably because I zoomed it a bit. That's okay. Usually I have this larger. Okay, I could. Okay, let me adjust that. So this is of course, but yeah, thanks for shorting this up before we do more stuff. That's locked. Can we move this also? Oh, come on. Ireland output. Why can we not? Oh, it's still locked. Did I not click it? I thought I clicked it. Do you need to see each and everything there? No, it's probably better, but now yeah, you get the idea. Pillar box it. Yeah, but so bin utils. The one thing I discovered, and that is also the thing, right? Why that is the difference between a successful Linux distribution or one of the other 2013 not as successful distributions. Because obviously we put already 25 years into it, but the only constant is change and regressions. And maybe I even shoveled some code around recently. I mean, obviously we are also changing, cleaning stuff up. And so what happens on this machine, because I have an adaptive serial attached SCSI adaptive SAS controller in here. That didn't came with the box, right? Previous video when I was actually wondering like where the heck is a SAS attached, or spoiler alert, it wasn't. So I had to buy a SAS controller. If you're lucky today, I have one more in the post. That is an adaptive Series 8 12 gigabit SAS PCIe. And today I should get a second one, because we're building a data center. I don't have so many SAS controllers. Obviously we need SAS controllers. I'm not sure what, it was a little bit strange what I ordered. I mean, obviously I ordered cheap stuff. What was it? All right, I might be a Fusion, because the chipset was a little bit clear. Was it Fujitsu or Dell? What did I order? But from Googling it wasn't instantly clear. It might be MPT Fusion or whatever. Something we will, like, yeah, obviously you need more than one SAS controller for you building your company and data center. But my point is, so what I wanted to say, long story short, also this didn't build. LTO wrapper, error building, loading, fatal error make, returned. That's not good. Okay, it failed in 3 minutes and something, and now we can't. That is something. So it sounds a little bit like what we supposedly had fixed, but maybe it isn't. But so to, oh darn it, we built some temperatures without keeping it. Oh, that was a good thing. Shit. Ah. Okay. Maybe we ruined our system. That is not ideal. Good reminder not to build without keeping your sources. What happened now? I mean, we could. I could SC. I don't have the Ryzen running. I need to pause it up. But what I wanted to say, a minute ago is, so this machine currently doesn't boot without network booting and stuff from our TFTP and bootp and stuff server, because our initRD only takes up, I mean, our initRD waits for root device, because obviously we, it's also SAS controller. Speaking of SAS controllers, exactly what I was waiting for. What's better than one SAS controller, two SAS controllers? So data center build up coming in. Yeah, looks clean. More liquid damage. Yeah, Fujitsu. So there's a problem with also Fujitsu and Dell parts. I mean, I could Google longer and longer, but that's like, we will see. I'm not plugging this in. I mean, it looks pretty new. It's supposed to be second-hand, but yeah, saving millions, being smarter than Oracle and Sun by buying not necessarily new, basically new old stock. Building a data center out of new old stock, saving 60, 70 or 80% with a simple trick. So I wanted to say, lost what? I wanted to say, so we have provisioning in our initRD, which of course this is one of the things that is mostly different between all the Linux distributions. Also, by the way, we should probably load or do I have this ISO line around here somewhere? Maybe not. Did I? No, I probably didn't. So we have a loop there waiting, like most Linux distributions, waiting for 10 seconds or so for a boot device to come up. And the reason for that is because this stuff is nowadays also asynchronous, right? 20 years ago, usually you had a PCI device and it was there. And nowadays, at times, like think good old IDE, ATA and SCSI. And nowadays, this stuff sometimes can take some 10 seconds. You know, you have epic thread ripping 5 GHz stuff, and then your fancy RAID stuff takes some 5 seconds to initialize or whatever. And firmware programming or device, or could even with SCSI, right? Even 20 years ago with Linux, but yeah, it was SCSI bring up probably was anyway more synchronous. Basically, they also refactored the Linux kernel for more stuff to be asynchronous, like SCSI drive or SCSI bus scanning and so on. Let's hope we have because someone noticed some ISOs were size 0, probably because of some network failure. That's also not ideal. Yeah. Also, we are revamping. Why do we all do all this? I said it 100 times. It's infrastructure here, right? So we will soon have, instead of rsynching this stuff like you did decades ago, we will soon have distributed storage and so on. That is why we do all this stuff. Obviously, I say 1.1 gigahertz. So yeah, that's old Firefox version on my Steam Deck. That's nothing to see. So let's curl that somewhere because we ruined our bin utils. And with something, let's actually, so yeah, coming back again, still not finished my sentence. So we have a loop there for waiting for root devices in sbin init. So also this is not standard, right? Every Linux distribution has it somewhere. We have init rd init there because I thought this is my invention. Also, spoiler alert, I am not a fan of most of the other init rd implementations. Yes, somehow I'm not a fan of a lot of stuff. Also, probably ours also not perfect, but at least ours is readable minimal and stuff. Probably could be more modular. The biggest criticism of our init implementation, which is completely unique, could be more modular. So probably, yeah, to do entry 512, more modular init. But my point is, so we have here a loop like for 10 seconds. By the way, we could probably further improve that. I guess we could increment that here, not really sure. But yeah, sometimes even but maybe because I have equals 0 and only printing that once. I mean, we could further, I mean, it doesn't really matter most, I'm just, no. But the problem is we don't reactivate, or like we don't rescan for LVM devices here. So we probably need to shuffle this code a little bit around, because what happened is you boot, our init tries to activate because I have this installed on a logical volume, it tries to activate the logical volume once, and that's not there yet. It's like trying to activate VG0/root, and it's like LVM2 is like, yeah, nothing to see. And then some seconds later the root devices appear on the SAS controller, and yeah. So we need to reshuffle this code, but yeah, we could do this in a second. What is also there? What is our curl? Oh, curl that. Mount ISO media, and so probably currently it's broken. RISC archive. Hello. This is also why we have a collection. Okay, okay, here it happens with lib opcodes. Hey, it turns out IBM Power stuff is. It's like 80 threads is more than 32, right, on my RISC. So maybe because of parallel installation, because we quirk, also like previous video, right, still 25 years later, not impressed with GNU-lib2, right, complete, utter, low quality shell scripting stuff and M4 macros. Yeah. Let's take a look into the log. Or did we? No, I think I didn't install this right. Media, let's install it. Yeah, that's a matching release. Should usually not matter the most, but it's always better to install nothing like And of course it shouldn't break, but that's what we're here for, right? That is all things required, all the attention to detail and testing. The only substitute, recurring theme here, right? I say this for 25 years and 4 years live on YouTube. The only substitute for testing is more testing, and the only substitute for performance is more performance, and threads is more threads. Let's see what happened here. Bin utils, so what happened here? Yeah, LTO wrapper. I thought error by loading. So probably that is similar, just that now it's also lib opcode. Like maybe it looks to me, I mean, it's difficult. You don't always see everything from log file, right? I mean, this is why then developers or field engineers request more data, because like, yeah, but you have the log. Yeah, I have the log, but it's like, yeah, thank you very much. Also, probably it should be possible to decipher from that Probably what happened is, like in the previous videos, that it installed something. It probably like parallel installed LD or AS, and that has S-frame and lib opcode. In which directory would that be? Probably, would they named it opcodes? Let's better check that. Utils opcode, okay, opcodes and S-frame, right? Or lib S-frame? Lib, one lib, one not, like, yeah, consistency. Who cares about consistency? So let's then also further quirk that. So probably, I probably was just lucky that it didn't, like this. I mean, the other issue occurred with parallel installation on my Ryzen, but apparently 80 threads more power. Who is surprised? 80 threads more parallel than 32 threads. So yeah, probably better all of those then, or can actually maybe we can do this in one line, right? Okay, let's maybe do this in 3. I mean, we could wildcard that. It's all lib, right? LDD. It's lib BFD, lib S. Yeah, I mean, of course it's all lib. Okay, we could wildcard that. Probably this should work in, if we wanted to do that. I mean, it's slightly more generic. It's probably should be fine. BFD, lib. Should be sorted alphabetically. S-frame and opcodes. Let's hope it doesn't have a typo. So let's see how accurate our estimate is. So probably we updated our. Yeah, it's not that slow, but it's single thread performance, obviously less than latest Epic thread Ryzen. I mean, it's so also this machine. I think the price of this machine probably when new some decade ago was also probably over 5,000 euro. I don't think it was 10. This is an tie-in open power, so tie-in cheaper than IBM. So probably at IBM it would be 10,000, at time it was probably 5,000, ballpark figure estimate. So, okay, building there, doing that to our init RD. Init RD init. So probably open Lux for LVM2 and resume from disk early. So the problem is even that could already be so the problem is, I mean, that is also the thing, right? Where you philosophically could think about so much embarrassingly like what. And that is also why Intel and AMD performance were at many cases preferable, because single-threaded performance, right? Because of I said this 100 times. It's just so long that now we thread rip that here, at least more. Yeah, now we get loaded. Like all the other time was single-threaded configure stuff, and why I constantly shout out. Like yeah, I mean it builds so fast when it builds, and I had the same thing on the very first. I said it before. Sun Microsystems loaned me. I'm obviously doing Linux for 25 years. I had a loan unit, a T1000, I believe, with what was it? Was it a T1 or T2? Was it a T1 processor? With what was it? This was also already cool thread. So was it? one processor. Or was it just 8 threads? What even was it? It's like, yeah, and that is the profile, and that's also why I'm not investing 5 or 10,000 euro dollar in a Threadripper or Epic, right? Because you would have the same profile, even today, sure, shorter and stuff, but you would have the same. That is the serialized configure build performance marginality I always talk about, right? So yeah, and I saw this, I knew this already for 2015. So yeah, over 15 years. Sun T, was it T1000? Actually, I have that here, but at that time I didn't save, for some stupid reason, I didn't save the CPU info. I should somehow Google it. That is hardware, server, Sun. Yeah, T1000 I had. Somehow I didn't save the CPU info because reasons. Yeah, still on Oracle Help Center, thank you very much. Is it Sun? Yeah, Sun T1. How many threads were that? Was it 8 or? Oh no, 8 cores? How many cores were that then? Because this was cool threaded. Was it SMT or? Oh no, was it just 8 cores? Or maybe it was just 8 cores and not SMT. So probably it was 8, or? Partition similar way. Oh no, 32, this the processor is capable of processing up to 32 threads concurrently. Actually, okay, apparently I remembered that kinda correctly. So this was only 32 watt at 1.4 gigahertz. And maybe, was it? Four threads, handle 4 threads. Okay, so 4 threads, so 8 by 4. The processor is capable of processing up to 32 threads concurrently. Okay, so that made sense as much. But yeah, I mean, this threads is like for I/O workload and stuff because you don't have that much. I mean, they're mostly waiting for each other's shared resources. And, yeah. Still didn't freaking fix it. I mean, how can Binutils installation be so broken? That's just like hilarious. Oh, okay, we just. This is our code. No, our code broke, fair enough. Oh shit, this is not... how can this be so annoying? It's ridiculous. Because it's not versioned, it doesn't have a dash. Why is this not freaking versioned like the others? Because I don't want to overwrite, or can we? I mean, we are built. We could also overwrite the symlink. So VFBFD dash, that is versioned. S-frame, that is not, and opcodes. Opcode is like, why is lib opcodes and why is lib S-frame not versioned? I mean, it's differently versioned. It didn't even, or was it linked to lib S-frame node? I think it, no, it's linked to, but it is, okay, fine, not lib S-frame here, would be too easy. Let's do that twice. So the number here is just priority sorting, right? We can use, at least as far as I remember, we should have multiple hooks with the same priority. It's only if it needs to be in some order, so like if some other stuff needs to be run early. But we don't need this in this case. Lib S frame we can, and lib, so no dash here, but not impressed. So let's build it here because I want to build this my primary. So And just because we found one implementation deficiency here or marginality in this code, we basically need to restructure that here. I really hate this because I mean we are supporting like a dozen different things of swap and early swap and resume. The thing is also that swap could be on LVM. And I know it already. I mean, yeah, that's also why more testing and unit testing. Because I know it already when I touch that here. It will break something. So basically, it always sounds so simple until you implement it. Like pro tip, try to implement something non-trivial. Basically, we kind of want everything of this in. All right, and only if we have a root device. Maybe I should actually. This is so crazy that even this becomes so complex that you kind of want to draw a diagram. Like, yeah, pro tip, also code design, right? Do not always. I mean, I usually just hack stuff here, but truth be told, we probably here at Extra Code, right? We are a real company and stuff. We are probably doing. I wouldn't be surprised if we would be doing more like code design than other companies. From what I see, most people in companies just hack stuff together, right, without real design. So you probably want to draw some flow chart for this stuff, and maybe even some use case diagram of what you want to support. Because we have classic devices that could, I mean, basically everything can appear asynchronously more than we accounted for. So classic LVM encrypted, but basically everything depends on the physical device can appear and will appear asynchronously. And how do we do that? The problem is that we cannot just test the device name, or can we? I mean, we need to remap it to, because the problem is even we have we could have hard-coded physical devices. LVM, the LVM name, maybe we should actually document which we even support. Here we remap to UUID. Poor man's remapping to UUID. Open loops for LVM2 and resume from disk early. But even that, so what do we have here? We have root. Right, I had here this fancy comma separated list of pre-enablement of devices. So we can't just put a while loop around it, because that would make, no we built my pre-install anymore. 3 minutes 31. Let's redo this and see. Okay, should we not have? Okay, that's not. Okay, so our scaling factor might be a little bit off. I'm surprised that this is so much off. I should also not have. No, I ruined our. And by the way, jumping here back and forth just to use my time efficiently. I don't want to have this. If I just focus on one thing for 10-20 minutes and the machine is idling, right? It's just what I learned. It might look a little bit unfocused, but I just got used to maximizing CPU power, CPU load, CPU resources, CPU time. Especially on slow machines or on loud machines, right? I mean, you probably hear it. is 50 dB. 40. Somehow it got louder right now. Yeah. Fan control is not IBM's or Tyan's strongest thing. Where was it in time? We have here this parallel scaling factor. I mean, we could increase it a little bit. The thing is, basically, I also wanted to test it right. We should have used emerge. The thing is, accuracy is good, but I mean, we can't make it super accurate for everything. Even for x86 on one Ryzen machine, on the same Ryzen machine, because the parallel compilation factor is simply different. I mean, we could theoretically store a parallel load factor for each package, because even Firefox has on Ryzen 6, Ryzen 17 or 50X, a 6-minute LTO, like Rust LTO, single-threaded bottleneck. So even on one machine we can't, with this approximation, make it perfect. 438, what was it? We had 3, right? How did it change from... Oh, this one. Okay, it's a little bit closer. Oops. Shit, we probably ruined our... Did we ruin our... of course we ruined our build time. Yeah, is it worth to... I mean, maybe it's not worth to optimize for this embarrassingly parallel SMT machines. So we also have, with the init.rd we could do this live, leave in the comments below. It's probably a little bit boring. It's too much guru meditation. So it's basically, the problem is just putting this into the while loop would activate the swap device also multiple times. So either we I mean, maybe we wait for the root device to be there, but probably, I mean, usually you have one type of devices, right? I'm just brainstorming, right? This is basically what is required, a little bit brainstorming, a little bit thinking. So usually you have the same type. I mean, if you have a SAS controller, then probably your devices appear in a similar time frame. And it's not like you have your swap on an internal IDE thing or a SATA thing. And I mean, you could, but so my point is, it probably makes no sense to activate swap before we have the root device, because it's probably a similar time frame. So it probably makes sense to move that a little bit over here, move that in one while loop. Wait for the device to be there. The only thing is it could be LVM, and for LVM we can't test if... Okay, we can check the device name or symlink. We probably should change. I mean, the thing is, you could address... I also don't like it. I'm not a fan of having... In my opinion, the LVM devices should all be in def, like in nicely named. LS block here. So it's like some block devices. It's a server. In my opinion, they should only be addressed as volume group name, like that. However, they are also here in mapper VG0 surf. So that is a generic LVM UDEF thing, which I'm not the super greatest fan of. Because if someone, the problem is, if someone specifies it in other ways, like how to detect whether it's a volume group thing or not. Also, I believe there was something with slashes, right? Was it with encoding slashes, with double slash? There was something. Yeah, because it would be a little bit annoying. I'm sure I'm a little bit micro optimizing here, but I don't want to make the experience worse, because so I personally don't like some things, like if it's printed repetitively, right? We could, where do we have, so basically this would be here, like mounting. So that is also, yeah, and then the other thing is, okay, we only should do this if we actually have a root. Why do we not, okay, this is resume. But probably we should, because the thing is, it needs to be implemented in such a way that it doesn't wait 10 seconds or so when it's an installer, because we use the same init-rd4 installer. So if no block devices, load some legacy drivers. Yeah, I think that's fair. That probably can stay here. I mean, unless we boot asynchronously, but okay, if you have completely nothing, then it's probably legacy. That's probably good enough. The problem is you can't detect IDE ISAR stuff. I mean, from user space, it's not like you want to probe some I/O ports and crash your PowerPC machine. So yeah, bin utils 3. Now we had that. Okay, now we build get text. So dry run force. So that's 440 versus, I believe it was 5 something, right? And it built in, I mean, a little bit off. I mean, sure, you could argue it's a minute off, it's 25% off or so. But in my opinion, this is good enough. It's a ballpark figure of how long will it take. So previously, yeah, it's from, I mean, maybe I tweak this default scaling factor a little bit. It helps also Ryzen. Truth be told, it helps estimating. I mean, it's because on Epic Threadripping Ryzen, our Linux time is also not estimated. It's the most accurate. Because the thing is, as I said, like Firefox builds in 93% parallel load because 6-minute LTO linking Rust, and the Linux kernel basically builds this 98% efficiency. It's like basically, it's pretty spot on, relatively good mostly. Yeah. How long would wow, it's guesstimating, like, yeah, they have it building. It's there. As much as I would like it, it's not in state-of-the-art machine, right? It's a decade old. And it shows, yeah. Also, maybe 73 minutes is off, like maybe we would build a Linux kernel in 50 minutes. Should we actually try that, just for kicks and giggles and stuff? By the way, does Rust work here on... Yeah, Rust works. It builds it in only. Okay, this was cached, it's not too... Whatever it cached here the first time was significantly longer for some reason. Okay. Also, I wanted to do one other thing. And that is, I noticed we update the reference time if it was a build error. That is, of course, also not ideal. Ref time. Where do we have that here? Do we do this twice? Probably, right? So only do that if it's not a build error. Store reference time and only... So build time is here. Yeah, I guess... if log, then Oops. Da. Compute relative build time to bin utils LFS times, store reference time, estimate initial reference time for in-system emerge. Ref time, oh, it probably should be fine. That probably should we test that? Because previously we clobbered our either Control C or build error clobbered our build time. It makes no sense to clobber the build time if it's anyway a what time? Why am I so hungry? Sorry, 12:30. So. Yeah, okay, root, we only need to do that once, so store that stuff. And open loops for OVM2, resume disk early. Yeah, basically all of this stuff potentially. By the way, what we could do is clear swap, right? A simple trick, like to only activate the stuff once, would be to clear the variable then. So where have I been? So root, open. Why do we do this only once? Probably because we have a comma here, because we have a comma separated list. So I guess all of this could be in a wait for device loops, right? And maybe only if we have a root device, right? So like probably do all of this stuff only if we have a root device. It's a little bit no, it's quite some rearrangement here. And then, but basically we could put that into a while loop directly. What do we have here? If root, then which other is this fee? Oops. But we could directly pair that with a while loop here, because we put we could print, I mean, initially we, that's the first thing, because I want to have that increment more visible and reliable at the beginning. So basically we could make this, that, and did I copy anything? Of course not. While is equal 9, what we previously had here. Something of that sort. Actually, maybe should we put this in? Actually, we could even further why have an explicit test if we can. Probably should work while road end. I could maybe better initialize that, not to have some random garbage in case someone assigns I in the top. Otherwise it defaults to 0 and this is also typo. Yeah, something like that. Plus some, it just needs some more restructuring. I will do this later. I'm currently getting too hungry. Basically, we did a lot of things that we wanted to. Why is bin? Oh, this is building get text, right? So what are we merging right now? Let's document the build time. That is what our hobby here of making our website more valuable resource. Oops. Yeah. Oh no, actually, difficult profile. So, tie-in 71 and stuff. Oops. Sun T4. So yeah, it is faster. Is it from a similar time frame? IBM Power 8 was released 2014. Okay, maybe it's slightly newer. Hey, it's not even 10 years old. Sun T4-1. Okay, it is, to Sun's credit, it is 3 years newer, something of that sort. Do we have the other still? Or did I? So that is 2.525, that is 22 nanometer process technology. And that is even 40 freaking nanometer. Where did they manufacture that? TSMC or? Foundry, wherever. Sun T4 Silicon Foundry. Where was it manufactured? Yeah, it'd be cool if someone... Ah shit, this is some bloody PDF viewing shit. Yeah, okay, fine, doesn't matter the most. Leave in the comments below if you know. So, performance. That was... $332. Bin utils, is it the same? Hello, why does this take so long? It was, maybe that is not the, what was the, yesterday I just ran it, was it not Y? What was version info? Got the name to my own, although to be fair, Claire implemented it. Some options here are a little bit cryptic. Q, Q not Y, of course Q. 3 13. Okay, let's a little bit faster. 13.1. Yeah, some, is it nearly twice? Was 5? New compiler. Yeah, also optimizing more. We probably built this a little bit. So maybe nearly twice as fast. Approximately. Yeah, we built smartest. The other we built lazy, so it's even optimized a little bit more. So, yeah. So, cool stuff. Process node technology is a thing. That's basically it for this video. I did what I wanted to do. Nothing like, it's only substitute for testing is more testing. Don't forget to use your precious Unix machines. Like, don't forget to undust and wrench some code every day. All right, we have some other stuff to commit. Oh, there's also a space at the end of the, how did that get in there? Do we have more of those? Hello, where's my cursor? Cursor? Here. Okay, this is just it. What? When you... It disappears when you search for space. What color scheme is that? You don't see the freaking cursors anymore. Okay, fine, whatever. So that's... Slide... Retune... Time estimate for very high thread count. Yeah. But I will probably stop it, right? There's a limit, of course. By the way, with this I skew the estimates for small packages on Ryzen, so there is not one. I mean, every package is different, right? For me, this is accurate, getting accurate enough. It's just a little bit tweaking to be some geometric mean of between all the outliners of build time. It should give you an estimate, right? Whether your UltraSpark 5 builds it in 5 hours or 10 minutes, right? That's the point. It's not like predicting it anyway vary, right? If you choose another optimization, this is for default reasonable optimization and actually LTO. So like if you build without LTO, it might be a little bit faster. If you optimize less, it will be a lot faster. If you optimize, like if you force optimize O3, because we build OS O fast, smartest usually, like if you force optimize for O3, it will be significantly slower, right? I mean, very theoretically, like if we want to overdo it, we could add scaling factors for O1, O2, O3 and stuff, but there's also a limit of overdoing, right? It should give you an estimate, like an approximate, reasonable, accurate time frame of when this stuff will complete. Let me enter a... Actually, yeah, basically that's it. You don't need to see me committing this other stuff. Basically it works. initID will further improve. All right, the bin utils, basically we found another bin utils, embarrassingly parallel bin utils install marginality, previous video, and that's what you get from testing every day, testing and coding every day. Keeps bugs away. Don't forget to share, like, subscribe. I hope you enjoyed to learn something, and to see you soon for all the next videos and live streams to come.